My name is Dr. Bubbles. Welcome to my research laboratory. Come on in. Wait! Before you get started with the experiment, we have to prepare ourselves. Safety and neatness are important in a laboratory. Do you already know what you need if you want to work in a lab? Click on the correct objects. Every door leads to a special lab room. On the sign next to the door, you can see which subject is being researched here. You use the arrows to move through the hallway and go into the different laboratories. As Tobias is watering his sunflower, he notices something remarkable. His sunflower always points its head and petals toward the sun, so it moves with the sun throughout the day. But why does it do that? Why does it need the light? This is where the term photosynthesis comes into play. I'm sure you've heard of it before. Let's take a closer look at the word. This complex word comes from the Greek and derives from the words photo and synthesis. Photo means light, and synthesis means putting together. Got it. So now we know that the plant needs light in order to put something together. That could be the energy it needs to survive. But let's take a closer look at what happens in photosynthesis in our experiment. Off to the material cabinet. You're already familiar with the material cabinet. For this experiment, we'll need a large glass container, a beaker, a stand, a lamp, a glass funnel, a splint, and a pipette. Great! Now we have everything we need. Let's get started. But before we can begin, we still have to prepare our lab for this special test and make the room a bit darker. That will enable us to make the photosynthesis in our experiment more easily visible. Use the light switch to dim the light in the lab. Great! Now the lab lighting is perfect for our experiment. For this experiment, I've brought you a water plant from the laboratory garden. We're going to need it because the plant produces a gas in the process of photosynthesis. Here. Very good idea. Now, you just have to find a way to move the photosynthesis in which the gas is produced underwater. Good job. The plant continues to produce the gas underwater as well. And thanks to our experiment setup, we can watch it happen. A few tiny bubbles are rising from the plant. Now we want to see what happens if we change the strength of the light. Think of a way that we can control the amount of light. Good job. Now we just have to switch on the light and off we go. What do you think happens now in the glass with the plant? Absolutely right. Switch the lamp on to see what happens. Good job! When you switch the lamp on, the photosynthesis intensifies immediately. You can see that by the tiny bubbles rising. Time to move on. Now we know how a plant reacts to being exposed to light. It produces gas. Now we just have to find out what gas it is. In photosynthesis, there are two gases that play a central role: oxygen and carbon dioxide. In order to find out which gas the plant produces, we'll carry out what is known as the glowing splint test. In other words, we have to bring the gas into contact with a glowing splint and see what happens. The first thing we need to do is to collect and capture the gas that is produced. Think about what objects we could use for that. Absolutely right. We need the funnel to capture the gas. But it might escape from the container again. We need something to stabilize the test setup. Well spotted. We can fasten other materials to the arm of the stand in order to capture the gas. Think about what we need to do next. Excellent. If we fasten the glass funnel to the stand, we can capture the gas. But hold on. How do we actually need to position the funnel? Exactly right. If you position the funnel over our plant in this position, you can capture a large amount of gas. The glowing splint test will work great this way. That's looking promising. Now all we need is one small thing to actually collect the gas in the funnel. We don't need this object this time. Think it over. Hold on. Good idea, but that won't quite do it. Think of a different way of solving the problem. We don't need this object this time. Hold on. Good night. Good job. Now we just have to switch on the light and off we go. Great! Our setup is finished, and now we can guide the gas that is produced into the funnel. It will take a few minutes, though. And we're done. The gas has collected in the funnel. Now we'll place the funnel back in the glass. That will put the gas under pressure. That, in turn, is the perfect prerequisite for the next step, the glowing splint test. But we'll need a bit more light for that. I've turned on the Bunsen burner for the glowing splint test. Use it to ignite the splint. Excellent. Now, quickly blow it out, and presto! We've created our glowing splint for the test. Now, we just have to let the gas escape from the funnel. Any ideas on how? Did you see that? After we opened the screw cap in our funnel, the gas escaped. The glowing splints really blazed brightly when exposed to the gas. But why is that? Why does the glowing splint ignite? Now we've proven that the escaping gas is indeed oxygen. Now you know that plants immediately start producing oxygen as soon as they are exposed to light. But the plant then emits the oxygen into the air, or in our case, into the water. I've brought you a plant that I kept in a dark cabinet for a few days beforehand. I stuck a tiny picture of the sun on one of the leaves. We'll now place this plant under our lamp and give it some light for a little while. Is there starch in there? It did have a total of 12 hours of light after all. Fortunately, we can easily detect starch in the lab. To prove the presence of starch, we use a bit of Lugol's solution which turns blue when exposed to starch. I've prepared a small bottle of it for you. To make the reaction more easily visible, I decolorized the leaf beforehand. So the experiment, pour a bit of Lugol's solution and water into the beaker, and then put the leaf in. Then we'll see what happens. Excellent. But we need a bit of water to dilute the solution. Add a bit of water to the beaker and then put the leaf in. Aha! Lugol's solution made the starch in the leaf visible. Everywhere where the leaf was exposed to light, starch was produced. Now we see the blue coloring. And where the leaf had the little pig. But now we want to take a very close look at what happened in the plant's leaf. For photosynthesis, the plant needs light and the gas carbon dioxide from the air. Then comes the water from the ground and chlorophyll. Chlorophyll is a pigment that is responsible for the green color of the leaves. Without chlorophyll, photosynthesis cannot work. The pigment can use the energy from the sunlight for the plant. In the process, carbon dioxide and water combine and are put together to form new substances. Do you remember? Light and putting together equal photosynthesis. Oxygen and glucose are produced in the process. The plant needs the glucose to grow, but the plant can't store the glucose, so it converts it into starch. The oxygen that is so important to us is more of a waste product for the plant, which is why it is emitted into the air. This confirms it. Without light, there is no photosynthesis. Without plants, no oxygen, and without oxygen, no life. Now we know why Paul's sunflower always follows the light. Without light, it can't live. So it grows in step with the course of the sun in order to get as much light as possible. And that solves the riddle of the sunflower. Now we just have to clean up the lab. Do you want to take care of that? Great! Now everything is clean and back in its proper place. Too bad that only works in our virtual lab and not in real life. You've successfully completed the experiment. I'm giving you a badge for a job well done. You can view all of the awards you win here in the lab on your tablet.